It's going to be a little bit different than what we learned in geometry. There's just going to be more to it. We're going to learn some extra trig functions that we've never talked about. You don't always have to use them, though, and I'll show you why not. Okay, so we're going to be looking at right triangles that have, again, this has to be a right triangle, okay, from this angle, which we're going to now use as theta. Okay, so you're not just going to use angle A anymore. They're going to ask for theta, which is just going to be an angle measurement. Okay, this from theta would be opposite, right? Okay, so this is your opposite side. Obviously, if theta was in a different spot, your opposite would move. What's the side called next to it? Adjacent. And then opposite the right angle is always your hypotenuse. Is that just how you remember it? Hippopotamus. Huh? Okay. I guess it's always the biggest one. Hippopotamus is pretty big. Okay. Our trig functions are going to be your sine, cosine, tangent, which we learned in geometry. And then we're going to learn cosecant, secant, and cotangent. Okay. Anybody remember the little acronym we talked about in SOHCAHTOA? SOHCAHTOA. So, for sine, out of SOHCAHTOA is what? Opposite over hypotenuse. I assume they're doing them in the same order, yeah. And I guess they're going to call this sine of theta. For cosine of theta, cosine is adjacent over hypotenuse. And then for tangent of theta is opposite over adjacent. Okay. The next three trig functions we're going to learn are the inverses of these. Okay. So your cosecant of theta, if it's the inverse of this, is going to be what? Hypotenuse over opposite. Your secant of theta is going to be hypotenuse over adjacent. And your cotangent of theta is going to be adjacent over opposite. Cosecant. Yeah, so you might want to write those words out possibly. Cosecant, secant, cotangent. Okay. Again, these are just the inverses of your original trig functions, sine, cosine, tangent. Okay, so what they're going to do in your assignments is they're going to give you a triangle. This is like what your first set of problems are going to look like. They're going to give you a triangle and they're going to ask you to evaluate the 6 trig functions for the angle theta. Okay? What's the first initial problem that I run into? I don't know the hypotenuse. Okay, I can find that very easily using what? Pythagorean theorem, which we may not have used a whole lot in here. Okay, but it's a squared plus b squared equals c squared, right? We also learned a special rule about this specific triangle in geometry, but I don't know that any of you necessarily remember it. What is this side? 13. 5, 12, 13 was a special right triangle for us last year. And 3, 4, 5, and 5, 12, 13. Okay? So, now we have to evaluate our trig functions. Okay? So, let's just do our original ones first. So the sine is what? Opposite over hypotenuse, so it's 5 over 13. I'm going to check and see if they want that as a decimal. No. Okay, that's what I would say. I'd say leave it as a fraction too. So sine is 5 over 13. Cosine is? So that's going to be 12 over 13. And then tangent is opposite over adjacent, so it would be 5 over 12. Okay. From there, we can figure out our cosecant, our secant, and our cotangent, hopefully fairly easily. Now this, they might have put theta in all these actually. Okay. I don't actually have to go back and think about, okay, well, what are they? Because I know it's going to be the inverse, right? So it's just going to be 13 over 5. 13 over 12. 12 over 5. I'm just going to flip all those. And that's going to be my other three trig functions. Okay. The catch you have to remember is you got to try to remember that cosecant goes with sine, secant goes with cosine, cotangent goes with tangent. I don't think you're ever going to mess the last one up, tangent and cotangent. Okay, but the first two are a little bit tougher to remember. Okay. We could do that, right? It's not getting too hard yet. Okay, so we're moving on to example 2, where it asks us to solve a right triangle. Okay. So they give us our triangle. They give us, this is 60 degrees. They give us, I'm going to use a different triangle if I can here than what you guys have. 15. Sorry, I'm going to change that on you guys. 62 degrees. We're going to skip down to example 3. Because if you can do 2, you can do 3. And then this is 6. That's not 15 anymore. Okay? We want to solve triangle ABC. Okay? Anybody remember what that means from geometry? It wants everything. It wants angles, sides. If it's there on that triangle, it wants it. So it wants you to be able to give me all of the angles and all of the sides. So I guess you'll probably have A, B, C in here. They'll give you those. Okay, and then remember, this is from geometry also, opposite angle A is side A. So these B and C will probably be switched because of Pythagorean theorem. Opposite C is side C. Just so we have variables so we know what we're talking about. Now in geometry I made you guys write out every single thing. I just need you to fill in what you're missing. Okay? So, can you find angle B? Yes. Pretty easily, right? Because that gives you 62. What does angle B equal? .28 degrees. Good. Okay, so there's one of my answers. That was the easy one, though. Now I have to try to come up with a way to find those other two sides without or while only knowing one side. If I knew another side, I'd just do Pythagorean theorem. Okay? This is where you have to use your trig functions. Again, we've done this. We did this in geometry. We did a lot of it. I have to use my angles and set up an equation with my sine, cosine, tangent and solve it. So, from 62, what function is going to use 6, and then do you want to do A or C first? A. So which one is going to use 6 and my opposite side? Tangent, because what two sides are those? It's the opposite and the adjacent. So I'm going to have the tangent of 62, because we said we're going to use the tangent, equals what? Equals A over 6. Okay. Well, how do I solve that? Yeah, so I multiply by 6, right? So I have tangent of 62 times 6. Be careful, because when you do tangent of 62, notice your calculator opened up a parenthesis. If you don't close that parenthesis, you get the wrong answer. So personally, I like to do 6 times tangent of 62, but it really doesn't matter, because I still close my parenthesis. So what did I get for side A? 11.3. Okay. Now, yes, I could do Pythagorean theorem to find that other side, but if I would have happened to use the wrong trig function or done something wrong and then use it again, I'm going to get the wrong answer, right? So I'm going to try to use this same stuff and not use something that I found. That's why I didn't use angle B also. I'm trying to use only what they gave me, if possible. So now I've solved that. I solved for B. I just have C left, right? What trig function uses the adjacent side and the hypotenuse? Cosine. So I have the cosine of 62 equals 6 over C. This is where your book is going to use one of those new trig functions. It's going to use secant, because I know that secant, instead of being adjacent over hypotenuse, is hypotenuse over adjacent. Okay, but anywhere on your calculator do you see a secant button? No. Okay, so personally, I don't like to use secant at all. Okay, I go ahead and I use my cosine, and I just solve for C still. You would multiply by C to get rid of your fraction, right? And then you'd have C times the cosine of 62 equals 6. And then I have to divide by the cosine of 62. Those cancel. Divide by the cosine of 62. Am I still going to get the same answer? Yeah, they just did it differently in their book. So I'm going to do 6 divided by the cosine of 62 this time. So I'm not multiplying, I'm actually dividing. And then I get my side length for C to equal 12.8. Okay. You guys remember doing that vaguely in geometry? Yeah. Hey, it should ring a bell. Some of you should probably remember it pretty clearly. I would hope some of you would anyways, because we did quite a bit of it. We're actually doing more of it this year than what we did last year, but we still did a decent amount. So, I have solved my right triangle. I was missing 3 things. I found all 3 of those things. Okay. Did I lose anybody? Okay. Just make sure your equation's set up properly. Obviously, if you use sine and it should have been cosine, you're going to get a completely wrong answer. Right? Yeah. if you did 6 over c and it was supposed to be c over 6, you're going to get a completely wrong answer. You have to make sure you understand, you don't really need cosecant, secant, and cotangent if you don't want to use them. If you just know your SOHCAHTOA really well, you'll be able to solve any of this that we're doing. Okay? So let's take a look here. There's really only one more problem I want to necessarily look at. It's example 5. Example 5, and before I do this, when we are, so let's say I'm standing outside looking up at the flagpole. Okay, so this is me. Smile because we're doing math. I'm looking up here, right? Here's the flagpole. Okay. Everybody sees my right triangle, right? Okay. We just have to understand some differences here. This angle, because on your homework it's going to use some of this terminology. This angle is your angle of elevation. Because I'm instead of going here, I'm going up. I'm elevating. Okay? You also have an angle up top, because there's another right triangle right here, right? Everybody see that one? Okay. That angle up here, though, is your angle of depression. Because it's starting here and it's actually going down. So like if you were standing on the edge of a cliff and you were looking down at something, you might be looking for your angle of depression instead of your angle of elevation. Does that make sense? So just be aware of that. They're going to use that terminology in your assignment. Okay, so last example I have for us. Hey, they have an airplane. That's an airplane. That's clearly an airplane. Okay. Anyways, the airplane is 30,000 feet up. I don't have to try it. It looks like an airplane without even trying. You want me to put windows in there? Door. Another door. There's always 2 doors for fire exits. Okay, so I have 30,000 feet. I have this length to my runway. So here's my runway. That's what we're trying to find out. And my angle of elevation is 10 degrees. Actually, that's not what we're trying to find out. We want to know... Oh, yeah, it is. We want to know how far is the airplane from the runway. Now, when you measure something, you don't include this angle. Hey, when you talk about how far I am from something, hey, if I'm talking about how far is it from here to Denver, do I take the elevation into account? No, it's all a horizontal distance. Okay, so I need to find this length. How far am I? I can't use Pythagorean theorem because I don't know this distance. But what function can I use, what trig function, to find my unknown length? Okay, I have my opposite and I want my adjacent, so that's tangent, I heard somebody say. Of what degree? tangent of 10 equals, again, if you mix this up, if you flip this wrong, it's going to make a big difference. You could use cotangent. All the book examples are going to use cotangent because it flips that. I don't like cotangent because can't plug it in easy in my calculator. I just know that I'm going to multiply by x and multiply by x, so I'm actually going to do what? I'm actually going to take, now, is it tangent divided by 30,000 or 30,000 divided by tangent? 30,000 divided by the tangent of 10, and I get what? What's my label? Feet. Could I figure that out in miles? How? Good. Divide by 5,280. It's 32.2 miles, right? Now, obviously, that sounds like a long distance, but on an airplane, they're probably getting pretty close. They should probably start losing some elevation there. Okay. You guys taking physics? You'll probably do. Okay. You'll probably talk stuff like similar to this with physics. Okay. Any questions? Okay. Again, mostly review. I mean, it should ring a bell to all of you because all of you have done it. I know that for a fact. I'm not saying all of you did your own work, Carissa, but all of you handed in the work. I am going to change this assignment real quick. We're going to add on tomorrow, yeah. We're going to do the odds today.
Wait till next Friday, I'll be sick. I wish.
Yep. I'm going to make sure tomorrow I don't want to give you anything extra. See what this looks like.